Hello. Welcome to this video of a very popular semantic subject, slot, entities, and intents. In this video, we will find out what these terms refer to and speak about some details of these semantic concepts and computational concerns. First of all, what is an entity or a named entity? Concept of named entity existed for a much longer time than intents and slots. A named entity is a proper noun group that is a given name to a real-world individual such as a human, a pet, a geographical place, a famous building, and so on. Here, important part is that the individual whose name is the entity should exist somewhere on the world or existed sometime in the past. Also, the entity should refer to a specific and single individual. Immediate examples. Notice that even without much context, if you already know these places or persons, the real-world individual, such as the person or the place, immediately appears in your brain. The following are not entities. First of all, the above expressions are not proper nouns at all, so they are not given names of any individuals. Second of all, they don't refer to specific individuals. Which dog is it? Fluffy or Minnie or Bug? Which girl is it? Julia from work or Whitney from the neighborhood? Have a look at the entity and non-entity word groups and compare them again, please. Now we come to intents and slots. These are two concepts related to semantic parsing of customer or user data. It can be a chatbot or a question answering system. What we want to achieve is that we want to understand what the user wants to achieve and parse some more specific information about this action as well. Then rest of the software maps this structured information to a well-defined backend action. That action can be generating an answer or firing a backend action, such as showing the user's bank account or package shipping info. Imagine you design a chatbot and user utterances like this lands onto your NLU engine. Obviously, this utterance includes a user wish, an action that user wants to achieve, which is canceling their card. Sometimes users don't directly say, I want to do this or I wish to achieve that. Have a look at these examples. The first sentence is quite explicit, but the next two ones are rather implicit. They describe a situation about the user's credit card, yet still they need an action. Your engine needs to recognize that this is a cancellation request. From computational aspect, we want to attach a label to each utterance like this. Labels here are the intent names. Okay. How one generates the labels? Usually we use statistical algorithms for classifying the user utterances. We train on labeled data, show example utterances to the classifier algorithm, and ask the predictor to predict labels of the unseen utterances. Basically, an intent is a label. Important thing about distinguishing intents, hence the labels, is that it should be a call to an action. These are suitable intent names. When there is an action, there is a verb. If we have a closer look at the intent names, we see that these names consist of two parts, a verb and an object. Indeed, these verbs are transitive verbs and the objects are direct objects. The following are not good intent names at all because semantics are not clear enough. You delete what or you cancel what exactly. The verb cancel can be mapped to many backend actions, such as canceling your money transfer or canceling your card or canceling your account. Another practical problem is that, as I said above, these intent names won't map to a specific backend action. You need to make one more pass over the user utterance and look for the object again. There are some exceptions, of course. You might need to treat some utterances special, such as chit-chat, a global cancer word, which ends the conversation, yes, no answers, and so on. For those ones, these intents are Totally fine. Only one word intent names are for special groups of utterances. Perfect. After the intent, then what is a slot? First of all, meaning of slot in English language is a long, narrow aperture or slit in a machine for something to be inserted. Literally like this, there are some places that you can plug in and plug out some objects of predefined and specific shapes. Slot in NLU is exactly the same. You can plug in and plug out similar words to some places of the sentence. Here is an example. 2 slot places. Plug in and plug out different words. Here, first slot is the main flavor and the second slot is the topping. Slots are tightly coupled with intents and the system design. Often there is a schema that you want to fill to fulfill the backend action related to a slot. Just like this flow, after detecting the intent, you need some more information. As you see, slots are features of the intent, not the individual utterances. Then who decides what are the slots? Answer is you and I, the system designers. We decided what sort of information is important for our NLU engine and the backend actions. Slot is the information we want to parse. Read it again. Slot is the information that we want to parse, yet a named entity is a linguistic concept independent from our NLU engine. Often entities fill some slots, though ordinary nouns can fill the slots as well. Here, entities, and here the ordinary nouns. Last concern is that slots needs to be nouns or noun expressions. You shouldn't mark adverbs or verbs as slots. This is a wrong design decision. It's not complicated, right? All one needs is to distinguish the concepts in the head. Semantics is fun. If you deal with customer utterances, it's even more fun. Well, then that's it. This is the last video of this playlist. More playlists are coming. Please stay tuned. And until then, bye bye.